Welcome back, and thanks for joining me again. It's time for us to get started for our first section here. Let's understand where did it all start from? What's the need to even talk about cloud these days? So before there was cloud, we had Commodore 64, right? So I'm just kidding. We really do not have to go that far, but that's what most of the people started their computing from. So these were kind of personal computers where people installed their games and different kinds of word processing applications and software. Maybe you had an accounting application where you would keep track of your budget as well. And remember that all of these applications and the application data was all saved on the computer directly. Well, as things evolved, something like a client server architecture was also created. So let's think about why we would need a client server architecture when everything was running good on that Commodore 64 machine. Think about a scenario where you walk into a grocery store or a retail operation or some kind of a outlet where the personnel maintaining the cash register has to communicate back to the central server for querying the information, maybe to get the inventory of the items that they have in the store. Maybe they want to query the cost of each item. What is the ID number for each item? And all of that information is centrally stored. And this is done so that the multiple computers or the registers can access that information parallelly. So that means that the information or the data gets stored centrally on a server. Now, why do we need to do that? So think about a situation where you have a server sitting out there and you're sitting on your computer and you start to update the data on that server itself. So there is no connectivity. So if that server needs to get information from a different network or a different server, there will be no way it could do that. You see where the problem is, right? Now, because the update that you made on that client server architecture is not reachable to this server, you have to connect it to the network as well so that your server gets updated information. So by creating a client server architecture, we are able to have multiple computers that are able to use that application and update it. So that's the importance or why we created the client server architecture. Now we know that client server architectures evolved over a period of time. So what we're going to do is replace this server with cloud, let's say. So instead of running applications in the server, now we are running it on the cloud. So your applications like Microsoft Office, your Word, PowerPoint, and all those types of applications, in many cases, they're all running in the cloud. And we are calling them as Office 365 these days. So even before that, we had things like Gmail, Yahoo Mail, or something like Dropbox where you used to store your data, or even Google Drive. And how about that Microsoft solution called as Microsoft OneDrive? What all of these applications have in common is that they are stored in a remote location. You got nothing running on your local PC at all. You're connecting to those applications using internet. Those applications are maintained and run by a third party, could be Microsoft or Google in this case. So this is kind of an evolution of client server architecture. It's just that we are not maintaining the server and the server is not in our premise these days. It's all in the cloud. So as things are evolving, we are seeing more and more applications being migrated from your client server design to cloud type architecture. So when we think about these applications, think about what makes up an application. What you need first is the compute. So think about compute as the brain of the operation. So compute is the CPU itself. And then what you will also need is the memory, which we call as RAM or random access memory. Now that's the basic component that makes up and remembers the activities done by your computer before they are committed off to a disk or to a storage. So these two components are kind of the primary components of your computer. We're talking about the CPU and the memory. So think about the days when you used to complain about the application saying that, hey, it's running too slow or too fast. That is because it's being processed slow or fast by the CPU and the memory together. Then there is the next component, which is the storage itself. So storage is where the actual data itself is saved and then where the application is saved. The storage could be the hard drive that's sitting in your local computer. It could be external hard drive that is attached to the computer to add probably the extra storage that you always wanted. Or in today's modern world, we've got cloud-based applications like Dropbox, Google Drive, or OneDrive. Now, these are all kind of large storage devices where you can actually save that data. So your storage location is where the data is saved. Let's circle back to the same situation where we're talking about the cashier who's trying to retrieve information about the inventory of items in the store. What the application would need in this case is a database, because in the store you got so many items and every item will have a unique ID, its own cost. So those IDs, costs, the name of the product needs to be maintained in some kind of a database. So the database is responsible to store that data in a structured way so that your application can easily search for the data and retrieve it as well. And then you got network. So networks is a little bit more of a discussion here. So let's think about your home network first, right? In your home network, you got a device that allows your house to connect to the internet. That device is typically something like a cable modem, might be a router, and that gives connectivity off to the internet. Now, inside your house, you got individual devices, and they may be computers, tablets, or even your phone. And these devices may want to talk to each other. They may want to talk to the internet as well for various reasons. So for your device to talk to each other, we typically need something called as a switch. Now, people do not have a full-blown switch in their house. They may have something called as a router or a SOHO router, small office, home office router that will perform the functioning of a switch. And all of that really happens in a simplified way that they all get connected to the switch device, and now they are able to talk to each other because they are all connected with that device. The switch will then allow the communication to flow through the internet. Now, anytime when you want to talk to something that's out there on the internet, let's say there's a computer out there that is housing something like Facebook or something, yeah? So when you want to access that Facebook, your computer communicates through the switch, through the router, to the internet, to something called as a DNS server. And why do I need a DNS server? Think of a DNS server like your contact list on your phone. So when you hit that button to invoke Siri on your phone and say, hey, call Mark or something, it's going to go and search for Mark in your contact list and then call him. So Siri now knows the name of the person and also the phone number because it's in your database. DNS is no different. DNS is like a mapping of your names, which is the website, with its IP address. So when you go to facebook.com, it's going to go ahead and look up Facebook in the list of contacts, let's say, on the DNS server and fetch the appropriate IP address for Facebook. So that's really an oversimplification of how it works. Remember that it's at a very basic level. We all need network to be able to communicate. So this might be your home network, this might be your office, or this might be Facebook itself. Inside each of these, we got a separate network, and all of these networks are able to communicate with each other over the internet. So inside every network, you got these basic components like compute, storage, database, and networking. Alright, now let's get into another topic called as server sprawl. What is that? In a corporate enterprise environment, applications grow really fast. And with the client-server applications theory, they are going at an exponential pace. So a lot of developers and organizations need to deploy an application, and every time they want to do so, they will go ahead and deploy a new server. And that means that with 100 applications, we got to have 100 servers. So even before the servers start getting fully utilized to their capacity, we have started to deploy new servers. That also means that there's a lot of unused CPU, unused memory, unused storage as well, and they're all working really hard. And the people who manage those servers kept on adding additional servers instead of consolidating them all on individual servers. Lots of organizations will have tens and hundreds of servers that are not being utilized to their full potential. So what started to happen from that is that many organizations started to face a lot of different challenges. One of those challenges is server sprawl, because the data center started running out of space. And setting up a data center is not something really cheap and easy to do. Running out of space is becoming a serious problem for a lot of data centers. They also have problems with being able to support the power requirements, because even if you're not utilizing the servers to their full potential, they still require certain amount of power and cooling for them to run. It's called as heating, ventilation, and air conditioning costs. So a lot of data centers started to really be challenged by not having enough physical resources to handle those applications that were being deployed. Additionally, think about the administrative workload of managing all that servers. So from a business perspective, you started to see a lot of challenges for things like we got to pay capital expenditure to purchase servers. You could easily spend hundreds of thousands of dollars on buying more equipment. So these are capital expenditures that several organizations may have to pay for, and the worst part is that they depreciate. What is the average life cycle of a hardware? Well, the average life cycle of any hardware equipment is about 3 to 5 years. So you can imagine the ongoing cost that many businesses will have to pay to maintain those applications. And then you started to have a distributed workforce. You got people working from home, people who are traveling, they're sitting in multiple offices, maybe in remote offices as well, and they have their own set of unique challenges to be able to allow people to access their applications. And you have to think about security concerns as well. How are they going to remotely connect to the data centers? Do you have a secure connection into the data center? Do you have a VPN as well? So you have to test the hardware, then the procurement process starts. And finally, you will provision them. All of these processes takes extended period of time. So this is just demonstrating how complex things can be with remote workers and the applications, need for more and more applications, and the need for space in the data centers. So how are we going to do this efficiently? How are we going to do this cost effectively and still keep it secure? That's where cloud comes into picture. In the upcoming lessons, we're going to talk about the muscle and steel that makes a cloud and how they are utilized. I'll see you in the next lesson.